This is our new Siemens 1200 GR series. Next to it are the digital input and output modules. On the side is the switch, which allows all communication systems to communicate through it simultaneously. This is our transformer. It converts a 120-volt signal into a 240-volt signal to power the frequency converter, which then drives our motor for motor experiments. Let's first take a look at the upper section. Here is the overall layout of the upper section. This is our circuit breaker. When the circuit breaker is turned on, it supplies power to the frequency converter. At the same time, our switching power supply provides 24 volts power to control all the 24-volt circuits below. The upper part of the blue panel contains our buttons, and these buttons can all be customized. In the middle area is our touchscreen, a 7-inch Siemens touchscreen. Below that are our buttons and selector switches. On the side here is our analog input signal, which allows you to select different frequencies through analog input. Here is our power switch and emergency stop signal. When the emergency stop is pressed, all 24-volt circuits lose power. This is our external 3-prong grounding plug, which protects our personal safety. Now let's power it on. Press the power switch, and at the same time, the circuit breaker closes. The entire system is now powered up. The touchscreen is powered, the PLC is powered, and the frequency converter is powered. Wait for the system to perform self-check. Now let's conduct a forward and reverse rotation test of the motor. Press the start button and the start indicator light turns on. At the same time, press the forward rotation button. The motor now starts rotating forward. The potentiometer can adjust the frequency of the inverter by rotating the voltage, thereby controlling the speed of the motor. At this specific point in the process, the motor gradually begins to slow down. Now let's test the reverse rotation of the motor. Press the reverse button, the reverse indicator light turns on, and the motor starts to slow down. At the very same time, our advanced inverter system is capable of monitoring the rotational speed of the motor in real time, ensuring that you have complete oversight of the motor performance and can maintain optimal efficiency during operation. At this point in the process, we are going to slowly rotate the control knob clockwise in order to steadily increase the power supply, which will effectively raise the rotational speed of the motor until it reaches its full operational capacity. At this point, the voltage is 10 volts and the speed has reached its maximum. Now let's test the emergency stop. After pressing the emergency stop, the entire panel loses power and the motor begins to slow down until it comes to a complete stop.